So, today, I want to make sure, it's going to be kind of a weird, not a weird day, it's going to be a paused day. So we're going to have questions on quadratic modeling, and I want to talk about your in-class exam on Wednesday. Make sure you guys know what, I finished making it yesterday. I sat down and kind of crunched through it. And I got it down to 2 data sets. One is tracking my son's weight from 0 to 6 months, and the other is Angry Birds. So I think between those 2 things, we've got linear, we've got quadratic modeling covered pretty nicely. So we'll chit-chat about that today. Make sure you guys know what to expect on Wednesday from that. Fair enough? We'll also finish up the modeling part of the course. We're almost there. We're almost at the end of modeling, which is coming up with equations for data. We're damn close. We're damn close. We almost finished it on Wednesday, but I didn't want to rush just to get it through. I figured there was one more type of modeling I wanted to look at real quick with you guys. And then, okay, did you have a question? You just get settled in. No. I saw a hand shoot. I wasn't sure. One more type of modeling that we can use by simulating a flu outbreak in the classroom. Not by actually getting anybody sick, but using random numbers to simulate a flu outbreak in the classroom. And we can show how exponential modeling is great, quadratic modeling is great, linear modeling is great, but there's one other kind that does a really nice job of describing what actually happens in the world sometimes. So we'll get into that today. Then that'll be all for today. Once we go over to homework questions for quadratic and get you guys set for Wednesday, finish up modeling, we'll call it a day. We might be done early. We'll see how time goes. Wednesday, you've got your in-class to take, and you've got your out-of-class to do. Okay? How many of you guys have gotten into the out-of-class? You can look at the, good, a couple of you. Yeah, there's a nice spreadsheet attached to it. You can kind of slide stuff around. It's like what we were doing with the bike, with me on the bike. Except you're looking at Usain Bolt's running when he set the world record in the 100-meter sprint. And it's interesting to look at his data, and I wish I started to give him credit for it, because it looks quadratic, but it isn't quadratic. And if you ever watch these guys run, or maybe the girls do it too, I'm not sure. But if you watch that particular race, you can see why it's not purely quadratic. It's not like me on my bike. It's much faster, first of all. But it's also, it behaves differently. The data behaves differently. So anyway, that's due on Wednesday, yeah? So make sure you knock that out between now and then. So what I'm not going to do is I'm not going to give you any homework between now and Wednesday, because we'll go over homework questions on the last bit of modeling the Monday of next week. Because I don't want you having to prepare for an in-class exam, do an out-of-class exam, and have homework on stuff that's not on the exam. Do the same day as the. You see what I'm saying? It's weird because of that Monday of last week having a Monday off. So. In other words, we're going to finish exponential modeling and this thing called logistic modeling today, which is no more than a different button push on your calculator. That's all it is. But we'll have that stuff due to take questions on Monday, a week from today. Christy, go ahead. We do, and I'll do the same thing I've done in the past 3 weeks. I'd like to push it back to Monday if you want. Did my email back to you make sense?
I didn't get it. I think I checked. When did you send it?
I got it on Saturday, I think, when I was up here doing work.
Yesterday.
I apologize if it didn't get through for whatever reason. I did send a great question. But what I'll do is I'll push that back till Monday as well.
Okay.
That way you have another opportunity. You can ignore exponential modeling until next week if you want to, and focus only on linear and quadratic. Although, in all honesty, it's not going to confuse you. It's not like learning. I could teach you like 12 different kinds of modeling today, and it wouldn't confuse you for Wednesday, because all it is a matter of doing is grabbing a different button in your machine and running a different regression. But I won't do that because that's dumb. Yes? Does that make sense? So let's just go real quick through this. We've got an in-class and an out-of-class for Wednesday. And we'll talk about that in-class first today. Wrap up modeling, call it a day. On Wednesday, we'll take the in-class part. It probably will not take you the entire day. I'm guessing it will not take you the entire class period. It might, but I'm guessing it will. I haven't designed it to. I haven't designed it to take the entire day. And I've got the introduction or probability, which actually Ariel's already done for us last week, so that was kind of nice. But I've got another reintroduction probability. We're going to finish off with that the remainder of the course we have together. Please.
And you said what was going to be on the in-class exam?
Just linear and quadratic modeling.
Okay.
Just linear and quadratic. Kind of like your out-of-class. Except your out-of-class is, if you look at your out-of-class, those of you that had, I actually have you fit a line, and then a quadratic, and then a cubic to the data. So you've already gotten a practice, if you will, except you have to use your TIs unless you want to haul a laptop in here to use on the exam. Tori, go ahead.
I was just going to let everybody know, if anybody wants to meet in Redmond, building 3 today at 3:15, there's 3 of us that are going to meet the out-of-class exam.
That is very generous, my friend. Thank you. Namaste. Or Namago to Redmond at 3:15. Very, very good. Yes, that was terrible. I'm sorry. It's terrible. But, yeah, sorry. These are the jokes, kids. Good. Thank you, Tori. Anybody hear that? Ariel, go.
So no average rate of change on the in-class?
I think I left that off the in-class. I kept it on the out-of-class.
Okay.
The reason I left it off the in-class was after watching how we got kind of bogged down in that together, I realized that might not be the best thing to have on the in-class part. So I'm going to have you guys finding models using your machines, and then simply plugging numbers in and popping numbers out, rather than doing the y minus y, x minus x. Your out-of-class takes care of that. So trust me, I pay attention to everything you guys say, and I learned quickly that was not the best thing to do, like in a time setting. So yeah, I left the average rate of change off, and the instantaneous rate of change is off.
Thank you.
Yes. Did everybody hear that question? It was a very, very good question. I think that the average rate of change, and I think I know why. It started getting more algebra-y at that point, right? It started getting more algebra-y, like taking these points and sliding points around, and x is y, x1, x2, y1, y2, and I think it started like tapping into this fear factor in the back of your brain. It's like, I can't do this. What the hell, yeah, you can. I know you can do it, but I don't want to have to try to overcome that and make you do it on an in-class exam in one day. So I just left it off. Cool? So no average rates of change or instantaneous rates of change in class on Wednesday. Your out-of-class part takes care of that. Yeah? Believable? Fair enough? Micah, go.
Quick question.
Yes!
Watching conic average.
Good!
On into.
Oh, I see. You're going with my competition. I see how it is. Are you hearing this? I don't have fancy markers. Or a budget. Or Bill Gates. Go ahead.
My question is, he kept on instantaneous rate of change in estimation. Why?
Well, was he doing it like we're doing? Was he picking points closer and closer and closer?
Yeah, and then subtracting them.
Mm-hmm. And the bottom, the denominator was getting smaller and smaller and smaller? That is an estimation. Great question. I'm going to give you the mathy answer.
Okay.
Give you the mathy answer. So, suppose, let's make the nicest possible equation we can quadratic. Quadratic. Make it linear. Let's make it linear. Nicest possible equation we can. I'm going to mute this. So you've got an equation like y equals, let's make it x plus 1, what the hell? Y equals x plus 1, okay? Now, if you're trying to find the instantaneous rate of change between 2 points on the equation of this line, you have to have 2 points. You have to have y2, or x1, y1, and x2, y2.
Right.
Now what you do is, to get the instantaneous rate of change, you slide these points until they're the same point. So you slide them closer and closer and closer until they're the same point. Well, the problem with that is if you look at the slope, the idea of a slope, change in y over change in x, if you try to plug the same number into both y's and both x's, you get 0 over 0, which is called indeterminate in mathematics. We all know what happens when you divide by 0. Awesome, ridiculous, impossible things. Right? Ridiculously impossible. You cannot divide by 0. I know why you can't divide by 0. You've always been told that, right?
It's undefined.
Why is it undefined?
You can't divide by those two.
Because you can't define by... Why can't you divide by everything else? What's so special about 0? Andrew has a good point over here. He says you can't divide by nothing. Why can I add nothing and subtract nothing and multiply nothing? You can't divide it.
Because it's like an undefined term.
But if I'm dividing by nothing, why wouldn't I just stay with what I had? Like it's almost like I'm choosing not to divide. Rush has a song about this. But go ahead. I love this. I love over here. This is a great conversation because you can't divide by nothing. I love this. Go please.
Just because you have to kind of stop at the first point where you try to start.
Hold that thought if you would. That's a great point right there. Hold that thought. You're hitting the limits in calculus. Hold that thought. Sherry, go ahead.
Or you can put as much nothing in something and you want to.
Now you're just trying to confuse me. Now you're just trying to confuse me, sister. Put as much nothing into something. I'm not trying to follow that.
I mean, if you're dividing by nothing, you can say it's anything you want.
But it's nothing. It's 0.
Right. So if I'm telling
Okay. I think I can tie what you and Andrew are saying together. Hold that thought, Benji. Give me a minute, okay? So let's just try to get close to dividing by 0. Okay? So suppose you divide by 10, 1 over 10. Well, it's 0.1, right? It's 0.1, no big deal. Now let's make 10 smaller, make it 9. What's 1/9? Ish. 0.11-ish. Ish. We see this? This is a great question. Almost. What's 1/8?
1.25.
Yeah, that's 1/8, which is 12.5%. Right? 1/7, it's about 14%-ish. Ish, somewhere in there. 1/6, it's about 17%-ish. We'll come back to that one on Monday when we talk about dice. What's 1/5? That's 20% exactly. 1/4? 0.25. What's happening as I'm making the denominator smaller and smaller and smaller? Say that again, nice and loud.
The result's getting.
Thank you, Benji. The result's getting larger and larger and larger. 1/3 is 0.33. Now watch how quickly it gets larger as we get closer to that 0 value. See, 0.1 to 0.11 only popped up by 1/100th. 0.11 to 0.125 went up by 1.5 hundredths. That to that went up by even more. If you do the finite differences between these, those differences are getting larger, aren't they? Right? Now look at this jump here. We jumped by, what is that? That's 8.08, 800ths, 8%, where it's only 1%. How about 1/2? Well, that's 50%, right? That's 50%. Okay? And then we go 1 to 1, 1. But now let's keep getting closer to 0. Let's make it 1 over 0.1. What's 1 over 0.1? It's 10. It's 10. Don't feel bad if that didn't pop into your head right away. You're not European. Because we don't deal with the metric system. If you dealt with the metric system every day, you would have no problem and recognize that as 10 right away. How about 1 over 100th?
100.
I just give you the answer. It's 100. How about 1 over 1,000th? Now what's happening? They're jumping up by orders of magnitude. Can you see the problem with dividing by 0 now? Technically, if you divide 1 by 0, it would have to be infinite to continue this pattern. And here's the mathematical reason why. You can't divide by 0. Oh, Benji, what were you going to say earlier? Go ahead.
You know, I'm the English guy, so
Okay.
the verbiage.
Oh, Ruben. This makes sense to you then. Sorry, go ahead. Not that kind of English. Go ahead.
Which I was the English guy. I love them better. We all do right. But yeah, the verbiage of multiplication. You know, one. You know.
Who's talking about multiplication? I'm talking about division.
I don't know. 10
Go,
is-
go.
Well, you know, 10. You know, 1 divided by 10 is how many parts of 10 go. You know, how many one things go in 10, and one of whatever the unit is can go and make 10 of that thing.
That's the easiest way to understand why you cannot divide by 0.
So an infinite number of gallons, miles, you know, whatever.
Right.
Yeah.
That's a perfect way of saying it, Benji. You'd have to take this number that many times to get to 1. 0.1 would have to be taken 10 times to get to 1. That's the definition of division. Division is the inverse of multiplication. You learn that at some point in your lives. Just like you never really learned about subtraction, except that it's the opposite of addition. If you can keep that straight, you don't have to keep 4 things in your head, only 2 things, addition and multiplication. And even then, you can make multiplication be shorthanded for addition. So if you can understand addition, everything else makes sense based off of that, but I'm getting ahead of myself. So this 9 times, hang hold that thought, this 8 times, this 7 times, and so forth and so on and so forth. This, that many times. Now this is where it gets weird, because now you're under a whole number of times, but you just take a fractional number of times of it. So, if you're taking 0 times something, 0 times what equals 1? Nothing. You can't do that, because as soon as you multiply by 0, which we can do, right, Andrew? We can multiply by 0. But what happens when you multiply by 0?
You get 0.
You get 0. You cannot get 1. You cannot get 1.
Why don't they teach this to us sooner?
They should have.
Yes.
Oh my God, if they haven't taught you this, they should have.
Well, I mean the 0 thing. I mean this. You lay it out in a way that it makes 10 times more sense than.
Here's why. Because I never understood this stuff sitting in the chair you guys are sitting in. I had to explain it to myself in a way that made sense. So I went back to nuts and bolts like I always do. I go back to, what do I know? What do I know? What can I buy? 1 plus 1 equals 2. Let's start with that. And just work up from that. I feel your pain because I wasn't good at math. I totally feel it. It didn't make sense. It was like magic. X plus 1 equals 2, so X equals 1. And I blame a lot of this on the fact that didn't take the SATs in 8th grade or 7th grade. I tested high enough on some standardized tests. Like, take the SATs in 7th grade. Worst possible thing you can do to a 7th grader. My dad, the engineer, sitting down trying to teach me algebra. Dad, I love you. It was traumatic as hell. Trying to explain what the hell X is to a 7th grader. I know a lot of kids are taking algebra right now in 7th grade. That's one of the worst possible ideas I can think to do to a 7th grader.
Yeah, I hate it.
99.99% of 7th graders don't have the abstraction ability to do that. But they're making them do it anyway. Anyway, soapbox off.
See, I thought it was easy to take algebra in middle school.
It's easy to take it. It's impossible to understand it. It's just like I could sit through a Spanish class, most likely and pass it,
Well, no,
and then speak completely awful Spanish when I got out.
I did better in math then than I do now.
You cannot measure that, Tori.
It's all changed.
You can't measure that you were better in math then. Because how do you you can't. It's an impossible measurement. You can't measure how well you understand mathematics. I can give you an equation, you can solve it. That does not mean you actually understand what's going on in the underlying part of it. I'm not criticizing you, sister. Please know that.
I understand what you're saying.
Yeah, please know that. I think about this all the
Could
time.
have done better doesn't mean you knew.
Correct. Now, here's where it gets crazy. Here's where it gets crazy. Crystal, hold that thought. Here's where it gets crazy. 1 was up here, right? Could we have done this exact same argument if there was like a 2 up there, or a 3, or maybe like a -5? I mean, yeah, the numbers would be harder to calculate maybe, but we could totally do it, right? Here's where it gets interesting. This fraction in instantaneous rate of change is where you have 0 over 0. Because both points are the same. You have 2 y's that are the same subtracted, which makes 0, and 2 x's that are the same that make 0. Good, Ariel. Good. Furrow the brow. Thank you. It's exactly right. Because then, this gets trickier, doesn't it? This is trickier than 1 over 0. 1 over 0 equaling question mark is a no-brainer. We know why that doesn't make sense. Because 0 times question mark is always going to equal 0. It can never equal 1. But can't 0 times question mark equal 0? And that's where it gets a little mind-bending. That's why the actual 0 over 0 in mathematics is called indeterminate. Indeterminate. And I encourage you guys, if you take more math classes, some of you are like, what the hell, I'm out of here, I'm done. But there's a really neat discussion about what 0 over 0 should be defined as. Because if you will, it can kind of take on different behaviors depending on what direction you're coming from. Very interesting. Andrew, go ahead.
Well, I was just saying, it makes sense because if you're trying to do like a point change and like this, or like how long it takes if you're going from 2 points in an instant moment.
The points have to be infinitely close, which means not different from each other. And that's where it gets into what's called a tangent line of a curve. So in your take-home exam, when you guys are sliding those points back and forth on that take-home exam, you're creating what's called a secant line. A secant line is you take 2 points on a curve or a circle or a parabola or any shape, connect them, boom, and it's called a secant. And when those points are far apart, that doesn't do a very good job of talking about how fast Usain Bolt is going at any given moment. Like for example, I can ask, how fast did Usain Bolt do the 100 meters on average? Well, we can totally do that, right? It took him 9.58 seconds to cover 100 meters. So his average speed is 100 meters per 9.58 seconds. Convert that to miles per hour so we understand it in English, and you're done. But does that describe how fast he's actually going? At certain points he was going that fast, right? He does have to be going that fast at certain points because he's accelerating smoothly. He starts at 0, he accelerates through that average speed and then pops off and then goes back down again, as you'll see. But it doesn't do a very good job of like talking about what's his fastest possible speed in that race, which is what I'm interested in, which is what blows my mind every time I recalculate it. Mike, go ahead.
So, but if you're doing that, wouldn't his fastest average speed have to be higher than the end result?
Wouldn't his fastest average speed?
Wouldn't his fastest speed have to be higher than the end result, which is his average speed?
When you say end result, you talk about average speed?
No.
Is that what you're talking? When you say end result, you mean his average speed?
Yes.
Yes, it would have to be, assuming that he's accelerating.
Okay.
Assuming he's accelerating, his fastest speed, his fastest IROC has to be higher than his average. Because remember my bike example. When we fit a line through it, which is the average rate of change for the whole trip, it overestimates how fast I'm going in the beginning and it underestimates how fast I'm going at the end. So somewhere in the middle I'm actually going that speed. But yes, assuming he's accelerating. Now assuming he's going linearly, no, his average speed is his instantaneous rate of change, but he's not going linearly. Cool, good question, please.
So since this is what I wanted to ask you, and since we're on this subject, 2 things. Where on one of the questions where it says how how fast is the previous speed in miles per hour? Are you talking about the one in number 4? Like if we,
Whatever one I had you do
because
right
there's a
before
couple
that.
of us that are kind
Just
of.
previous means the previous.
Question, okay. And then on what you're talking about with the speed and the fastest he's going, do you want us to move the thing to get to where exact, even though the line, so if the line's here and the
I
line-
refuse to answer that question because I want you to explore.
Okay, because one of us got one thing and one of us got another.
Then talk to each other and see who's doing it more correctly.
We don't know.
Then talk to each other again.
Okay.
And bring somebody else into the discussion.
Okay.
Bring somebody else into the discussion. I can't say much about that one because I give it away if I say anything about that. I give it away if I say anything about that, I give it away. So
Because
that's why I can't say
I moved
anything.
the line.
Okay?
Okay.
Okay, so Micah, that's what he's talking about. The reason it's an estimation is because all he's doing is, he's not actually making the 0 over 0. He's making the distances between these two essentially look like this. 0.0001, 0.00001, 0.0000000000001. So I mean, the idea is that's still an estimation. But as you saw on your take-home quiz for my Blake, it doesn't matter. Once you get out to a certain number of zeros, you're getting the same exact result to the nearest whole number. Just like with Usain Bolt, when you guys are sliding those points, as you slide, I will tell you this, Linda, about that spreadsheet. As you have the one sheet, there's the one sheet where you can move both points back and forth. You can slide those points, and if you're watching the instantaneous rate of change up top, it'll go to UND, I think, or UND with a pound sign, or UNDF. That means undefined. That means you're creating this situation right then at that moment. So if that happens, just back off a little bit. Because you can't, Excel's doing the math. Excel's not doing the calculus. It's doing the arithmetic. It's doing what you guys did. It's doing what Khan's doing. Does that make sense?
Well, I guess my biggest, where I was really confused is he took one point and another point, and averaged them together, and the average he got was higher than the actual center point on his.
It depends on the curve you're talking about and where you are on the curve. See, the thing about this, I have to actually see what function he's using. That's why I erased it now. It started with the equation y equals x plus 1. I never ended up using it, which is okay. But depending on the curve, so if the curve does something like this, and you are doing the average rate of change from here to here, well, clearly, that curve is below that bad boy. So if you're taking the y values, now imagine taking the average rate of change from here to here, which would be 0.
Right.
Or from here to here, which would be negative, here to here, which would be positive. It all depends on where you are on the curve and what kind of curve you have. And I can't answer that without seeing which curve he was actually using. Do you remember, was it cubic, was it quadratic? It was quadratic. Was it upside down or right side up? Was the slope of the line increasing, decreasing, or 0?
It was increasing.
There you go. So he was going, it's kind of like this. Look, kind of like this, the situation then. Yeah. So right here, at this point to this point, you're forcing a straight line growth where there is not a straight line growth. It's actually dropping, then catching up.
Okay.
Does that make sense? On average, this is what I deal with as a bike commuter every day. Speaking of which, this is what I deal with as a bike commuter every day. When I'm at a red light, I do a track stand. Why do I do a track stand? Track stand is when you're balancing the bike, both feet in the pedals. Why do I do that at a red light? Any bike commuters in here?
So you make the time up once the light turns green.
As soon as that light turns green, I'm going. I can get across the intersection before the car behind me even starts going. And that's because the car behind me accelerates like this. Or as I essentially accelerate like a straight line. So the point is, this is actually not exactly right. This is kind of what's going on with me. I'm the red line, the car is the black line. Both the car and I are sitting at the intersection at 0. 0 time is the moment that thing turns green. As soon as it turns green, boom, I'm gone. Now I accelerate, but it's essentially instantaneous. I can get right to my top speed pretty quickly. Why do I do that? Because I can get across the intersection before I meet up with the car. Now when I say meet up with the car, I don't mean hit the car. I mean the car passing me. The car will eventually pass me on an open road because it can go faster than I can. But not over a short distance. In a short distance, I can beat the car across the intersection until it accelerates enough to catch me. That's why I do it. That's why I do it. Now, this average rate of change, if you think about it, both the car and me, we both cover the same distance, correct? In the same time. In the same distance in the same time, but nothing could be different with how we did that. I did it all in a straight line. That car did it by slowly increasing from 0. But it's still the same average rate of change.
Okay.
Even though if you watched us go back and forth next to each other, you'd realize there were two different things going on. Is that fair? Good. It's very interesting mathematics. There's a lot based on this mathematics. It's very algebra-y though, and that's where I learned a couple weeks ago to back off the algebra smidge. That's where the Excel sheet can help out. You can explore without actually doing the algebra. Yes? Good. Okay. Now, as far as Wednesday's in-class exam, should we want to talk about that a little bit? Just to put your minds at ease about what's going to be on it. Okay. So I think I got it down to 10 questions, 5 points a pop. I think. Let me start.